Okay, we are back. This is Techmath1. We're looking at Chapter 3 for review for the second test. And here comes the problems. So the first one, it's just cross, multiply, and solve. So we've got that given. Here, let me get my blue marker out. Let's put it over 1, cross multiply. That's 3p equals 8. Divide both sides by 3, and p equals 8/3. Done. Next one, cross multiply and solve again. It'll be 4x is equal to 1 times 3x minus 1. So it's just going to stay 3x minus 1. And then you subtract 3x from both sides, and you end up with x equals -1. Next one, this is a little trickier. You put it over 6 over 1, cross, multiply, and solve again. So we got 6 times 3 times k minus 1 equals 1 times 2k. So this is actually 18 times k minus 1 equals 2k. And then do the distributive property, and so 18k minus 18 equals 2k. And then I'd say let's move the k's over to the right side. So minus 18k, and here I'll rewrite it up here. So that leaves us with -18 is equal to -16k. And then you always divide by what's in front of the variable. So divide by -16, divide by -16. And now we want to just reduce it. Lowest terms. So 18, 16 is a negative, divide by negative is a positive. And then divide by what? 2 and 2. So 9/8. So k is equal to 9/8. All right, this one, before we cross multiply and solve, we actually have to get it by itself. So we'll write that negative on the top. You can put it on the top or the bottom. I'm going to put it on the top. -3 over 4w equals 3 over 1. All right, and then cross multiply and solve. So we get 12w equals -3. Now be careful on this. We divide both sides by 12, and a lot of students accidentally put down -4. It is not -4, it's 3/12, -3/12. So you divide by 3 top and bottom, it's -1/4. So be careful with that, not to fall into the trap of seeing 12 and 3 and just thinking 4. All right, the 12 is in the denominator, not the numerator. Okay. This one, cross, multiply, and solve. So we got 8 times f equals 3 times quantity f minus 1. Don't forget to do the distributive property. Most common mistake here, people forget to take the 3 times the -1. You got to do it both. 8f equals 3f minus 3. Red rover the 3f over. We got 5f equals -3. Divide by 5. And f is equal to -3/5. And we're done with that one. All right, let's go on to number 6. Again, hopefully a lot of this is review that we just remember, you know, how to solve proportions, cross, multiply, and solve. Here's number 6 is 4/3 p minus 3p over 2 equals 1. So in this case, I don't want to work with fractions. You can do it with fractions if you'd like. I don't want to. So I'm going to multiply everything by the common denominator between 3 and 2, 1. And so the LCD is 6. So I'm going to take this times 6, and this times 6, and this times 6. But not really. I mean, you can if you want to. You could do top times top, bottom times bottom. And that's like 6 over 1. So that's 24/3, which is just 8. There's another way to look at it. 8p. If you don't want to do it that way, you can do it this way. It's how most students do it. You do 3 into 6 twice, and then you do 2 times 4 is 8. That's maybe a little easier. It's like you're reducing it first instead of using the bigger numbers. We could do the same thing here. 3 times 6 is 18p over 2, and so that's going to end up as 9p. But if you'd like, you could do it this way. 2 into 6 3 times, and 3 times 3 is 9. And that might be an easier way of looking at it. 6 times 1 is 6. So then we have that. Easy peasy from there. After you get rid of the fractions, it's an easy problem. You combine like terms, they're on the same side. So that's negative 1p is equal to 6, and then divide out the negative 1. So p is equal to negative 6. Let's look at 7. Same dog, different fleas, right? 5 minus 2 over h is 3 over 2h plus 7 over 4. So we look at this and say, okay, what is going to eliminate all of the fractions between h and 2 and 4? The LCD would be 4h. Now, if you're not sure how that happened, let me show you. H is just h. 2h is just 2 times h, like you're breaking them down into the primes. 4 is equal to 2 times 2. So then first thing when you're finding an LCD, you take what they have in common. So they have a 2 in common, they have an h in common, but then you also take the leftovers. And so that's 4h. 4h is the smallest thing that all of these things will go into, all right? So this gets a 4h, this gets a 4h, this gets a 4h, this gets a 4h. And now I've had students ask over my career, hey, why are you just multiplying it on the top? I thought you had to do it on top and bottom. No. It's an equation, an equal sign. And so I'm taking the whole left side times 4h and distributing it, and the whole right side times 4h and distributing it. So that's why I don't have to do it on top and bottom per problem. Like if I just had an expression, I was trying to find common denominators, that's when you have to do just the top and bottom thing. When you've got an equation, you can multiply both sides of the equation by anything you want. And instead of doing the distributive property, it's just easier to just tack it onto the top of each one. All right? So now look at what we have. We have 20h minus, the h's cancel there, 8 is equal to, the h's cancel there, 2 goes into 4 twice, 6, the 4's cancel there, plus 7h. Much easier to work with, right? And so we'll subtract 7h from both sides, get 13h, minus 8 equals 6, then we'll add 8 to both sides, get 13h equals 14, and then divide by 13 on both sides. And get h equals 14/13. So I want you to show your work when you're doing these problems. Again, if you want to be fancy and write 1 and 1/13, you can. You do not have to. You can just leave it improper. I'll make sure that doesn't happen, the same thing that happened on the first test that it said, hey, we don't want that kind of answer. I'll make sure that doesn't happen again. All right, so there we are. 14h, or 14, h is equal to 14/13. Again, show this work, the minus 7 on each side and the plus 8 on each side, because again, very, very common mistake. People decide they don't want to show that work, and they just see a -8 and a +6, and then they put down -2. Well, you have to think about, how did I get rid of that -8 with a +8? How did I get rid of that +7h with a -7h? Okay, so definitely show the steps, show the work, and that does help to get you the right answer. Okay, so on to the next one is number 8. So m is equal to 2d over d minus little d. And then they tell you m is equal to 10 and big D is equal to 8. And now you just sub in those values and then solve. So m is equal to 10 and big D is 8. And so now we just 8 minus D. And now after, you know, a little fixing up here, it looks just like the problems that we did before. Cross multiply and solve. And so that is negative 64. So negative 10D is equal to negative 64. And then I divide by negative 10. And now this one, they gave me context. This is a length. So I'm not going to leave it 32/5. I'm going to actually divide it into 6.4 inches. Okay. So since we have the context of inches, we'll use decimals. Now, does that mean, I would still give you credit if you wrote down 32/5, but that's a really weird way to give a length. So I guess 6 2/5 might be even better if you're a carpenter and you don't want 0.4 inches. All right, so either one though is fine. I'm going to give you credit for either one. It's just in this case, decimals do make sense in the context of the problem because it's a length. All right, so now, oh, this one is a little harder to set up. Number 9, we've got cars that one car is driving the same amount of time as another car. One's going 10 miles per hour faster. So how fast was each car driving? Okay, so they don't want the time. That's okay. So we have distance equals rate times time, dirt. And we actually have it twice. There's two things at play here. We've got the faster one, the 290, is equal to the rate plus 10, because this said it was going 10 miles per hour faster. And then they said the same amount of time, the slower car, 240, and that we're just going to say rate times time, like that, right? So now let's solve this for time. So we're going to divide by r plus 10, divide by r plus 10. So we have time is equal to 290 over r plus 10. That's the fast car. The slow car, divide by r, and at 240 over r is equal to t. All right. So now I think the context of the problem, they said, okay, some guys, no, it's just driving at the same time. All right, so the same amount of time they covered. This one covered 290 miles, this one covered 240 miles. So they gave us the distances and they said, this guy's going 10 miles per hour faster than that guy. And so we set them up, but they said the times are the same. So what that means is I can take this and sub it in there because the times are the same. So I get 290 over r plus 10 is equal to 240 over r. Now, I've had students say, oh my gosh, I did 3 of these on the assignment and I don't want to set it all up like this. Do I have to show all that work? The answer is no. If you're very familiar with the problem and you want to jump right to this setup and say the faster car is going to be over the faster rate and the slower car is going to be over the slower rate, and that's going to just equal. You can jump to this step if you've gotten familiar enough with the setup. That's fine. So cross multiply and solve. We get 290r is equal to 240 times r plus 10. We do the distributive property. We got 290r is equal to 240r plus 2400. We subtract 240r from both sides. And like terms, we can subtract them. So 50r is equal to 2400 and then divide by 50. So r is equal to 48. That's miles per hour for the slow car, which means the fast car is going 10 miles per hour faster than that. So r plus 10, 48 plus 10 is 58 miles per hour for the fast car. All right. Okay, let's look at the next set of problems on the review. This is the chapter 3, 4 review 2. And so these are a little easier than the word problems, I think. So write out, so I'm not going to write it out. It says write 703,015. So how would you write that? 703,015. So no and in there. All right. 11, they want us to take 0.0792 and square it and then round to millionths place. So we put that in our calculator. To put that in your graphing calculator, 0.0792, you hit the caret key and then hit 2. Or, you know what, I think it also has an x squared key. Yeah, you could just do that too. 0.0792 and then hit the x squared key and then hit enter. And so either one. The caret key is good for 2 or 3 or 4 or 5 or anything. So if you do it that way, that's fine. But it saves you one button. If you hit the little x squared button, it'll just toss the squared up there for you. So that is 0.0062724. So now we have to know our places: tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, and then this is 10 millionths. So we actually look at the one directly to the right of it to see if that gets bumped up or if that just gets truncated off. And it is going to get bumped up. So 0.00627 3 is the correct answer for that one. All right, 12, convert to a fraction in lowest terms, 20%. So we take that 20%, first you make it into a decimal by moving it 2 places to the left, and then you ditch the percent sign, right? And so 0.20, that's the same as 0.2, 2 tenths. If I read that out loud, 2 and then tenths place, 2 tenths, that's this, and then I reduce that fraction. 1/5. So 1/5 is equivalent to 0.2, which is equivalent to 20%. So sometimes you'll see people do that with statistics. Instead of saying, oh, 20% of the people die when they take this, they'll say, well, 1 in 5 have an adverse reaction, you know, and so they both mean the same thing. It's, most of us understand percentages better than fractions. And so that's why I'm always a little worried when they start throwing fractions up there at you. All right, so let's again, 13, convert 0.65% to a decimal. That's kind of tricky because it's a really small percent. So remember, to go from a percent to a decimal, we did that right here. We moved it 2 places to the left. I still move it 2 places to the left. It's just a really small number, 0.0065. Okay, so be careful. They're trying to trick you there. Trying to get you to write 65, making you move it the wrong way. Convert to a percent, 0.0425. So if it's a decimal, to make it into a percent, you go 2 places to the right. So 4.25, and then we put the percent on. Now that, I do need you to put that percent on for me. That's the one time that I really do care about the labels, as if you're giving me a percent. All right, so 15. Convert to a percent, so 3/10. So you put in your calculator, 3 divided by 10, that's 0.3. And now that's a decimal, we want to make it into a percent, so 2 places to the right, 30%. And we remember to put that percent sign. Okay. Okay, so then 16.8. 0.8% uranium in ore. How much uranium is in 2,000 kilograms? Okay, so 0.8% percent of uranium in ore, and they have 2,000 kilograms. So what you want is what is 0.8% of 2,000? That's the question at hand. What is X? Is means equals. I make that into a decimal. That's two places, so 0.008. Of means times, and 2,000 still means 2,000. So we're talking about 16 kilograms of uranium for that problem. 17, to make 260 kilograms of bronze, they use 223 kilograms of copper. What percent is copper? So yeah, there's a couple of ways to do this. I think the easiest is just think of what a percent is. It's part over the whole times 100, and that's going to be the percent. So think of it as a test. What if you got 223 points out of a test that had 260 possible? What would you get? Well, it's the part over the whole and then times 100. And so that would be 0.85769230077. That's what you get when you divide 223 divided by 260. And now let's convert that to a percent, and it says round to the nearest tenth of a percent. So that means first you make it a percent. So first things first, make it a percent. 85.769230077 percent, and now tenth of a percent. So we look at this. If this is 5, 6, 7, 8, or 9, that gets bumped up. All of that's going to go away no matter what. So 85.8%. All right. Let's look at, I forgot the E on bronze when I wrote it out. Sorry about that. The spell check didn't work on my pen when I was writing it on the paper. Okay, so we're looking at 18. That is how many liters of a 20% solution? Let's see, how much time do we have here? Oh, 22 minutes. Okay, I'm going to do a part 2 with the word problems.